the matter in our surrounding. And in this chapter, there is one topic of the melting and the boiling point. So, here in this chapter, this topic, although it's a very easy topic, but it has some nitty gritties inside it. So, we'll understand why this melting actually happens and what this melting point actually denotes. So, as you have if you have read this topic, you would have found that the melting point of a solid is an indication of the strength of the force of attraction between a particle. This is the statement that is given in the NCERT book, that the melting point is an indication of the force of attraction. What it writes? Force of attraction. Force of attraction. And this force of attraction is actually what leads to a melting and boiling point. So, but why this happens? So, we first have to understand in the melting process what actually happens is the material is a solid, and this solid is actually, when heated at a particular temperature, that is, there is a change in the temperature, there is some heat that is being provided, and then it gets converted into a liquid. So before we deal into what the melting and the boiling point is, we have to understand that what is a solid and what is a liquid, because these two are the phases of matter, which actually decides why the extra heat or extra temperature is required for changing their state from solid to liquid. So why we call something a solid and we call something liquid? Why? On what basis? See, when it comes to the solid, we talk about two, three things. One is the shape. In case of the solids, the shape is constant, almost. We call it a rigid shape. In the case of the liquid, it is not constant. Okay? And in the second, we talk about the volume. The volume is constant here. Here also it is constant. So what changes here in case of the liquid? What we find here, the difference between a solid and a liquid is only this shape that is not constant in case of the liquids, it is constant in case of the solids. If we go deeper into, let's say it's a solid and this one is a liquid. Now, if I in case of the solid, if I get into the microscopic view of the solid, we'll find that all the molecules are actually arranged in such a fashion that they will not move. They have a proper force of attraction among themselves. So all the particles are actually connected with a force which is called as the, when you will be reading in the higher classes, it is the electrostatic forces. Okay? So what we mean by the force? Force is a pull or a push. So here, what kind of force will be there? It will be a kind of the pull that is being generated. Why? Because when we will be getting to higher classes, we'll learn about that positive and negative charges, like two magnets, north and the south pole attract each other. Similarly, positive and the negative charges also attract each other. Like poles repel, and unlike forces, unlike poles actually attract. So in the same manner, unlike charges attract. So when the unlike charges attract, this means that there is a full strength between two molecules inside the solid. But what happens in case of the liquid? See, in case of the solid, this bond is actually in not only a bond which is because of the two molecules, it is actually because of the lattice formation that actually happens when it case when it is a solid. So all the molecules are attached with themselves in such a fashion that they will not move. Only what they can actually do is they can only vibrate a bit. Okay, only vibrate from the initial to the final position, they can only vibrate. And because of that vibration, what happens is they will not be moving from this place to this place. They will always remain in one static position always. Only the thing that they can do is the vibrate at a certain position. Okay, only they will vibrate. But what will happen when it is a liquid? So we'll check. In case of the liquid, what happens? The molecules are open to move. Acha, here in case of the liquid, what happens? There is no such proper forces of attraction. Like there are some forces of attraction, but they are actually weak, and that's why because of the weaker force of attraction, what happens? That the shape is not fixed. They will change their shape often. Okay, they will change their shape often. This means that let's say one person is pulling the other person is pulling the other person. This person has good strength, and this person also has good strength. Like you have seen that in case of that rope game where we will um, pull from both the sides. What happens? The rope becomes very tight, but if let's say the strength is not that strong, it is weak, the two people are weak, the rope will not be that tight as in case of the strong people. So similarly, what happens in case of the solids? This attraction is very high, but in case of the liquid it is not too high. And because of the weak forces of attraction, the distances between the particles, as the distances increase, the force of attraction also decreases. So sometimes this distance is very high, sometimes it is low. So here there can be a good attractive attraction force, but here it will be less attraction force. In total, the liquids will not be having great forces of attraction. Okay, so from there we understood that in case of the liquid, what happens that the forces of the attraction are weaker. The bonding is not that strong, and because of the weaker forces of attraction, what happens? Their shape changes. Sometimes it is like that, sometimes this molecule will move here and this molecule will move here, this molecule will move here. Now the shape changes. Okay, now the shape changes. So that's why we learned about it, that in case of the solids, the shape is constant. In case of the liquids, it changes. What about the volume? Volume remains same. Okay, because volume does not depends upon the shape changes, volume remains same. uh, it is actually the same kind we can understand from the rubber band, that if we stretch the rubber band which is maybe like this, if we stretch it, it becomes slightly thinner, but it is stretched. So in total its volume will remain constant. huh? the liquid actually behaves in this manner. If I compare this with a rubber band, the liquid, it behaves in this manner. The volume remains constant. Only thing is that it changes that shape. The shape gets changes. That's why there are some solids for which we use a term called plastic property. Okay, what does that this actually mean? uh, there are some solid, like if we talk about sugar piece, if we see it is purely solid. Okay, but what about the rubber band? The rubber band is not purely solid. It is solid, but it, as we apply the forces, if the forces apply, it changes its shape. This means that the rubber band is not having a constant shape. But as we remove the forces, if the forces are removed, then again it comes to the original position, original shape. This means that the shape remains fixed. Now, should we call it a liquid or should we call it a solid? Actually, we call it a solid. Why? Because in case of the liquid, their shape changes and it is not in our control. But in case of the rubber, its shape changes, but as we remove the forces, the it will regain its same position. It will regain its original position, and because of the original position, it is called as the solid itself. But these kind of solid will be having a high plastic property. We generally call these take a different term for these: elastic or the plastic. Elastic and plastic solids are there. So we'll discuss about it when we go into the higher classes. Now, coming to the topic, the melting point, what actually happens is, in the melting point, the solid which were actually having their original position fixed. This means that when they will be having their original position fixed, when the bonding between the two particles inside the solid is constant, this distance is constant, it does not changes. What will happen in case of the liquid? The distance between the two particles, mm, like this, if this is the liquid, if this is the bonding at a particular time, if I see right now, this is the bonding. So if I see after 1 second, I will find that they have changed their shape, and this might have moved to a different position. Let's say this might have moved to this position, this might have moved to this position, to this to this. Now if I find the new position, we'll find that this is the new position. Okay, this is the new position, and this means that the body has changed its shape. Here in case of the solid, this actually does not happens. So how we can say that, how we can do that, such a thing, so that the body actually changes its shape? This will be done with the help of providing nothing but called as the heat. What heat will do? Heat will provide some energy. Heat is what? We have learned in the earlier classes, heat is nothing but an energy, a form of energy. So this energy, when imparted to the solid, what will happen? It will actually get inside these bonds. The bonds will become weaker. Why the bonds become weaker? Because see, when we provide the heat, these all molecules, see, these are the bonds. These actually do not occur in nature, but these are the forces which are invisible. We actually, just for the explanation purpose, we make some bondings like this, but these are actually invisible things. So these molecules, when we provide the heat to them, what they will start vibrating even more. So they will move from many position, they will start moving like this thing. At their original position, they will start moving. Similarly, this molecule will start moving at its original position like this, again this thing. Similarly, for other molecules, it will happen in the same manner. Now, what happens if this is happening, if they start moving in a if they start moving like this, in this fashion, what will happen? At one point it was here, it was here. At some point it will become here, this will become here. Now earlier the distance was this, now the distance has increased. Okay, so why the distance increased? Because of the heat imparted nothing but the energy, and this energy got converted into the kinetic energy of the particles. Okay, what is the kinetic energy? Kinetic energy is the energy that actually happens because of the motion of the because of the motion of the because of the motion of the particles. Now so now you might understand this thing that as distances increase, this distance is increasing. As the distances are increasing, this distance is increasing, the forces become weaker. Forces become weaker, and as the forces become weaker, there will be a time that they will start moving haphazardly. If they are in this distance, now the distance becomes like this thing. Okay, so they are quite apart. It is almost the same thing that happens in case of the liquids. Okay, so this energy, where does that energy go? Because we have imparted the energy, where that energy went? It is in the motion of the particles in the form of the kinetic energy. And this particular kinetic energy that gets inside the particles, that is inside the particles, is stored inside the particle. It does not melt the particle because the particle have only started moving haphazardly. They are still in their intact position. They have not, the solid has not converted into liquid. Until and unless the distances become so high. So until and unless the distances become so high, there is some energy which is taken by the solids, by the particles inside the solid. This energy, when taken by the particles, is nothing but the latent heat. Okay, is nothing but, we have observed that there was some latent heat of fusion that happened in case of conversion of solid to the liquid. So this particular energy, which actually does not convert the solid into a liquid, but starts the behavior of the conversion of solid to liquid, is called as the starts the conversion. It only starts the conversion. Okay, now this energy, this particular heat energy that is imparted, that becomes the part of the latent heat of fusion. Okay, fusion, why? Fusion is generally a term which is used for conversion of a solid into a liquid, and that's why conversion of a solid into a liquid is called as a solid to liquid is called as the fusion. So that's why latent heat, latent means hidden heat. Okay, latent means hidden. Why hidden? Because this particular heat is actually not converting a solid into a liquid. It is only a hidden heat that is there, which is not converting the solid into a liquid. It is only starting the particles to move haphazardly in their own position. But after this particular heat is imparted, there will be a point at which the heat is so high that the distances between the particles will become very high, such that the forces of attraction, the forces of attraction becomes so low that they will start moving in any manner from their original position. Okay, here they were moving haphazardly, but they were moving in their same position. The position was this. They were moving around this position only. But now what has happened, after the lot of heat is given, they have changed their position. They have started changing their position, and that's why this particular point at which they have started changing their position, now their position will be this, their position is this, and this. So now this kind of a structure will be made. Huh? So this particular structure will be called as a liquid, and that point at which this happens is called as the melting point. Okay, so we'll summarize now the whole thing. So first we had studied about what is the difference between a solid and a liquid, and how the force of attraction actually leads to the different phases of matter. Okay, because only thing that decides whether something is a liquid or a solid, that is its shape, and shape is decided by the force of attraction. And force of attraction, when becomes weaker, it changes its shape, it changes its phase, phase to from solid to liquid. Then we studied about how, after providing the heat, the particles started moving or vibrating at their original position. So initially when we heat something, what will happen, all the heat will be consumed, and all the heat will be consumed, but the state of matter will be same. State of matter means it was solid initially. State of matter will be same, and this particular heat is nothing but called as the as the latent heat of fusion. Now there will be a time when this latent when all the particles are vibrating so much, so that if even a small heat is provided, they will change their position. So when they start doing this thing, that they start changing the position, this means that the state of matter changes. And because the state of matter changes from solid to liquid, therefore we call this as the melting point. Okay, so that's it. So this is the whole summary of this particular topic. Okay, thank you.